about SR latch using NAND gate. Okay, previous class we discussed SR latch by using NOR gate. S means set, R means reset. So, okay, here we are implementing with the NAND gate, and it is example of a sequential circuit. So output depends on the present input SR, S and R, and past output Qn and Qn bar. Okay, and you are going to get next state output Qn plus 1 and Qn plus 1 bar. Okay, right. So the S and R are the present inputs, Qn bar are the past outputs. So Qn plus 1 bar are the next output. Okay, now so here gate 1, gate 2 are cross coupled with each other. Gate 1 output is given to input of the gate 2. Gate 2 output is given to input of the gate 1. Okay, right. So here output is always in the complemented form. If Qn bar, Qn is 0, Qn bar will become 1. If Qn is 1, Qn bar will become 0. Okay, na? So hence we are only going to find out, so Qn plus 1 only. We are going to consider only Qn. If you know Qn, automatically Qn bar is the complemented with Qn only. Okay, right. So let us go to the truth table. So try to understand the truth table, right? Okay, here how many S and R are the present inputs? Qn is the past output. These two are the present inputs. Qn is the past output. So here I am not considering Qn bar. Only I am going with the Qn output only, because if you know Qn, automatically Qn bar is the complement form of Qn. Okay, na? So the S and R are the present inputs, and Qn and Qn bar are the past output. So then we are giving these inputs to the NAND gate 1, NAND gate 2. After that, you are going to get next state output is Qn plus 1. Okay, right. Let us discuss. Okay, now first condition we will take. Let us take first condition: S equal to 0, R equal to 0. S equal to 0, R equal to 0. I am giving S equal to 0, R equal to 0. Clear? Now gate 1, for gate 1 I am giving S equal to 0, but I don't know the Qn bar. I don't know the previous or past output Qn bar. So hence I am assuming, so I am giving 0 0, but I don't know about the past output status of this Qn or Qn bar. Hence I am assuming whenever I am giving 0 0 as my input, if my past output is 0, so what is my next state? And same again I am giving 0 0. If my past output is 1, what is my next state? Because I don't know, I am giving only 0 0, but this is the S or present inputs. I don't know the past output. Hence one time I'm assuming 0, same 0 0 I'm taking again. I'm assuming if output is previous output is 0, what is my next state of this latch? And the same inputs I'm taking 0 0. If my past output is 1, what is my next state? Okay, na? So input SR we are giving 0 0, but past output, if it is in case of 0, what is the expected output? The past output is 1, what is my expected output? Okay, right. So here I'm giving 0, and I'm assuming Qn equal to 0. So this 0 is coming here, and so here SR. Okay, before that we should understand NAND gate output. Okay, na? So A, B NAND gate 0 0 0 1 1 0 1 1. First, for understanding, we'll take AND gate. What is AND gate? A, B, no? AND gate. So if all the inputs are high, output is high for the AND gate. Okay, now I'm going to take NAND gate. NAND gate is opposite to the AND gate. This is a NAND gate. Okay, so opposite to the AND gate, 1 1 1 0. NAND gate is opposite to the AND gate. Okay, right. Now let us take here, this is a NAND gate. So whenever NAND gate is input is 0 0, so one of the two inputs are 0 0, my output is 1, so it can produce the output is 1 in this here, and this one is going as input to this gate 1. Now 0 1, now 0 1 0 1, whenever I am giving 0 1 to the gate 1, my next output is also 1. Okay, na? So here it is a 1. Okay, now we got same. So here we got Qn bar is 1, similarly Qn also 1. Okay, na? So Qn equal to 1 I got, and qn bar also I got 1. So we should not get same output because qn and qn bar are complemented with each other. Okay, na? That's why it is invalid. For example, if I'm getting 0, I should get qn bar equal to 1. So output must be complemented with each other. But in this case, here I got 1, and here also after doing everything I am also getting 1 only. So here output I am getting 1 1. So we should not get 1 1. Okay, na? So that is a invalid state. Okay, let us go with another example for understanding. Okay, now I gave 0 0 as my input, and I'm assuming the past state is 0. No, now I'm going to assume same input s equal to 0, r equal to 0. I'm assuming my past output is 1. My past output, look at here, right? So here 0 0 I'm taking here. So I'm taking 0 0. Okay, I'm giving 0 as well as this is also 0. Okay, na? So I don't know the previous output, no? So I don't know. So for this gate 1 I'm giving 0 as my input, but I don't know the qn bar. That's why I'm assuming qn equal to 1. Now I'm assuming qn equal to 1. This one is coming here, this one is coming here. Now what is the gate 2 inputs? 0 1. Gate 2 inputs 0 1. So 0 1 means it will produce 1 as output. Now this is the one I am getting as output. Now this one is going input to the gate 1. Now 0 1. Here 0 1 again I am getting 1. So here qn bar I got 1. After this, so my gate 1 inputs are 0 1. Again I am getting 1 as my output. So here also same qn bar I am getting 1 1 only. So we should not get like this. So qn and qn bar we should get in the complemented form, but I am getting 1 1. That's why. So both cases I observed. In both cases I got invalid state. Okay, na? Okay, this is a case 1. Now I am going to discuss about case 2. Okay, now I am going to discuss case 2. Clear? Now in case 2, what I am taking here now, right? Okay, now I am going to talk about case 2. Okay, now here I am giving 0 input and 1 input. So s equal to 0 and r equal to 1. Now gate 1, one of the input is 0. So another input I don't know about qn bar. That's why I'm going for. So I'm assuming qn equal to 0. If the past output is 0 along with 0 1 input, what is my expected output? And same input 0 1 I'm taking, and if the past output is 1, what is my expected output? Okay, now so 0 I have given, but I don't know the qn bar. Another input I don't know. Hence I'm taking qn equal to 0. This is a qn equal to the past output is 0. So this 0 is coming here. Now 1 0. So 1 0 means what? What is my output? 1. It can produce a 1 as my output. This one is coming here. Now here different inputs are there. Here different inputs are there. 0 1. I'm going to get 1 my 0 1. Now I'm getting it out. 1 is my output. Okay, now right. I got 1 output. Clear. Next, another state I'm going to take here. 0 1. Okay, now same 0 1 I am giving, but now in this case I am assuming my past output is 1. I'm assuming my past output is 1. What is my next expected output? If my past output is 1, so this 1 is coming here. Both are 1 1. Whenever 1 1, it is gives 0 as my output. Now 0 is here. Again this 0 is coming here. Both are 0 0. I'm getting my output is 1. Okay, na? Right. So in this both the cases I got next state is 1. Okay, na? So I'm going to take another example, case 3. Okay, so let us discuss the third state. So input is s equal to 1, r equal to 0. S equal to 1, r equal to 0. Now gate 1 has one input, but I don't know this qn bar input. Hence I'm taking now. So I'm giving 1 0. If my previous output is 0, I'm assuming previous output is 0. The 0 is coming here. Both are 0 0. Both are 0 0. So output is 1. So qn bar I got 1. So this one output is given to input of this. Now this will become 1. Both are 1 1. What is the output? 0. Okay, na? That's why I wrote 0 here. Next. So another state I'll take and I'll give the example. Next state is what? 1 1. Sorry. So again I'm giving 1 0. So this is a 1 and this is 0. right? I don't know the previous state here. Okay, na? I'm giving 1 0, so 1 is here, right? 0 is here. I don't know the previous state. In the previous case I assumed 1. Now I'm going to assume, sorry, 0. Now I'm going to assume 1. So if the qn is 1, this one is coming here. Now 0 1, okay na? So what is it? 0 1. Now what is the 0 1? 0 1 I got, so output is 1, no? I'm getting 1. This one is coming here. Both are 1 1. Both are output is 0. I got output is 0. So here also I got 0 as my output. Next state. I will go to the fourth state. We will go to the fourth state. Now fourth state is 1 1. Fourth state is 1 1. Okay. Right. Okay, now my fourth state is 1 1. Now s equal to 1, r equal to 1, but I don't know qn bar input of g1. That's why I'm taking the previous output is 0. 0 I'm giving here. The 0 is coming here. Now both are 1 0. Whenever 1 0, I will get, output is 1. So this I'm getting 1. This one is coming here 1. Now both are 1 1. Both output is 0. Now I got output is 0. So 0 I wrote. Next. Another case I'll take. Okay, na? Okay, another case I'm giving 1 1 only, again 1 1, but the previous output I'm considering 1. So 1 1 and previously I'm considering 1. So now this I'm taking 1. So this one is coming here, right? Now 1 1, both are 1 1, no? Output is 0. So it is producing 0 as output. The 0 is coming here, now 0. 1 0 means, so output 1 only. So I got 1. Okay, now that's why I got 1. So this is also called as no change state, means previous, this present state is same as the previous state. This present state is same as the previous state. That's why it is called as a no change state. Okay, na? Next, here in this case the output is 0 0. So independent of the previous two past outputs, I got my next state output is 0 0. That's why it is called reset. Reset means 0 0. Okay, na? Next, this is a set state. So set means 1 1. Set means 1 1. So independent of the past outputs, this is a past output column, no? Independent of the past outputs, I'm going to get my next state is 1 1 only. Okay, na? So in this case, independent of the previous states, I'm going to get my next state output is invalid or undetermined. We cannot estimate. Okay, na? So this is about uh, SR latch using a NAND gate. Okay, so you may get confused during this. So I'll give one clue. By using the clue, you can easily remember. Okay, na? That I'll explain now. So last class I discussed about SR latch by using NAND gate. Now in this class I'm discussing about SR latch using previous NOR gate. It is a NAND gate. Okay, na? Right. So it is example of a sequential circuit. So here present inputs will be there and past inputs. So after giving present inputs and past outputs, I am going to get then my next state is what? Qn plus 1. Okay, na? Right. Okay, let us continue this. Okay, how many inputs are there? So S is a present input, R is a present input, and Qn is the past output, the next state output. Because of these two are present inputs, and these two are present inputs. This is a past output. Okay, na? So these three are inputs only. So present inputs and past output. That's why how many variables are there? Three variables: S, R, as well as Qn. S, R, Qn. That's why. So three variables, no, 8 combinations: 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1. Okay, na? Right. So now after this you should come here. So you should write I S R N. ISR. I means invalid state, S means set state, R means reset state, N means no change state. You should write ISRN. Okay, na? Right. I means invalid means so independent of the previous states. Independent of the previous states, I am going to get XX only. Means invalid state, undetermined state. Next, S means set. Set means what? Independent of the previous states, my next state output is always we are going to get 1 only. After the reset, Reset means independent of the previous states, I am going to get my next state is what? 0 0. N means no change. No change means previous output and present output both are same. That is called no change state. It is a SR latch using NAND gate. Now, similarly, same thing I am explaining here. I am going to explain SR latch by using NOR gate. SR latch by using NOR gate. So here NRSI opposite. Okay, na? So here NRSI. It is a SR latch using NOR gate, SR latch using NAND gate, opposite. So you should remember SR latch using NOR gate, SR latch using NOR gate, NRSI, you should remember. Okay, now you should remember NRSI, NRSI. If you remember this, okay, now so that if you remember SR latch using NOR gate, so we can easily derive this SR latch using NAND gate is opposite to the SR latch using NOR gate. So here reverse. This is reverse now. ISRN. Okay, na? Right. This is the reverse you should take. So or bottom to top you can take. Bottom to top. ISRN. Okay, na? So this is about SR latch using NAND gate. Okay, na? Simple. So SR latch using NOR, NRSI. SR latch using NAND reverse. ISRN. No change state, reset state, set state, invalid state. Invalid states, set state, reset state, no change state. Opposite with each other. Okay, now first you should remember three inputs. You should remember three inputs, and after that you should come here and remember ISRN for SR latch using NAND, NRSI for SR latch using NOR, and if involved means you write just here write XX, set means just write here 1 1, reset means just write 0 0, no change means previous state and present state both are same. It is a SR latch using NAND, and opposite nothing but what? NOR. So N means no change, R means reset, S means set, I means invalid. Okay. Okay. Thank you very much. Thanks for watching this. Okay.